Hi guys, so in this video we're going to look at what's called independent events, and you can see I've written underneath there an independent event is when one event has no effect on another event. A very quick example for you is if I throw a die that has absolutely no effect on whether I get heads or tails if I toss a coin. Those two events are completely independent of one another. And the definition of an independent event here is that the probability of E intersection F is equal to the probability of E multiplied by the probability of F. And in general, if two events E and F are independent, we can prove it by showing this. Either the probability of E, given that F has already occurred, is equal to the probability of E. The other way around, the probability of F, given that E has already occurred, is the probability of F. Or the probability of E intersection F is equal to the probability of E multiplied by the probability of F, which is this one here, and this is the one that we generally use. So let's have a look at an example. So example 1 says a blue die and a white die are thrown. E is the event that the number on the blue die is 3 greater than that on the white die. F is the event that the total of the numbers on the two dice is 7. Let's find the probability of E, the probability of F, the intersection, and then we'll see if these two events are independent. Okay, so let's have a look at the probability of E first of all. So I, probability of E, and this states that the number on the blue die is 3 greater than that on the white. Now the easiest way to do this is to just list them, I suppose. So if we look at white and the blue die, we know that there's going to be hash n in this particular case is going to be equal to 6 times 6 because there's 6 outcomes on the blue die and 6 outcomes on the white die, and it says that the number on the blue die is 3 greater than that on the white. So if this is 1, then that'll be 4. If this is 2, that'll be 5. If this is 3, this will be 6. There are no other ways that we can actually have what we've just said there in the question. So there's only 3 ways. So this means that the hash R, just from very quickly doing a very quick sample space there, it gives us 3. So the probability of E here is equal to 3 over 36, which is equal to, divide everything by 3, 1 over 12. Okay, so there's E done. Let's have a look at the probability of F. So the probability of F, so it says the event the total numbers on the two die is 7. Now again, we can very, very quickly get that out. We know we can get 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. Okay, again, the number, our hash n is equal to 36 because that's what it's 36 different, or the total number of outcomes. So this one here, hopefully you can see that the probability of F is equal to 6 over 36, which is equal to 1 over 6. So we now have the probability of F, and we have the probability of E. Now we want E intersection F, so where do both of these happen? Well, hopefully you can see there's only one place where I didn't really label this, but there's only need to, but I'll label it now. So that's the white and that's the black one. We're looking for where these two events both happen at the same time. So 1, 4 is not going to happen because it doesn't add up to 7. 2, 5 adds up to 7, 3, 6 doesn't. So the only thing that is shared between the event E and the event F is 2, 5. Look, 2, 5 here and 2, 5 here. So that means there is one outcome that is shared, i.e. the intersection. So the probability, so just go to the side here, the probability of, and this is E intersection F, is equal to, and it's 1 out of all of the outcomes, which is 36. So we now have answered part I. Part II states, investigates if E and F are independent. So if independent, then we know that the probability of E intersection F will be equal to the probability of E multiplied by the probability of F. So we just need to check to see if that's the case. So what we have here is we have 1 over 36 is equal to the probability of E, which is 1 over 12, multiplied by the probability of F, which is 1 over 6. And 1 over 36 is equal to, well, 1 times 1 is just 1. 12 times 6 is 72. You can see that this is certainly not the case which implies that these are not independent. And it's as simple as that. Again, the hardest thing about these is getting the intersections and getting the probabilities right in the first place.